We're solving problem 14 from the 2023 AIME 2. A cube-shaped container has vertices A, B, C, and D, where A, B, and C, D are parallel edges of the cube, and A, C, and B, D are diagonals of faces of the cube. As shown, vertex A of the cube is set on a horizontal plane P, so that the plane of the rectangle ABDC is perpendicular to P. Vertex B is 2 meters above P. Vertex C is 8 meters above P, plane P, and vertex D is 10 meters above plane P. The cube contains water whose surface is parallel to plane P at a height of 7 meters above plane P. The volume of water is m over m cubic meters, where m and n are relatively prime positive integers. Find m plus n. Now, for this problem, it says like all these points are this many meters above plane P. However, we can convert that into a more easily readable form. So we let h of x be the distance from point x to plane P. Oh shoot, it's like this, fancy P. So then we have all these values listed out, and then we can let the distance of AB to plane P, I keep on doing that, be alpha, and then AB is A, AC is therefore A root 2, and then we have this property here that gives us h of s is equal to h of g is 7. Now, that's going to be important for later, very important for later. But for now, we want to work with this. From this, if we have tangent of alpha, this is sine of alpha over cosine of alpha by definition. This is equal to h of b over ab times ac over h of c, capital C, which is equal to root 2 over 4, therefore giving us a equals 6. That is very important, and we will need it later. So what we can do now is we can start using these values and start really just working with them because we have their points like listed out and their actual value. So we can do h of c minus h of g. This is obviously 1 because we have their values, a 7 and 8. And then we're going to have h of d minus h of I. H of d is 10 and h of I is 7. That gives us 3. And then we're going to have our third thing, h of e minus h of f is equal to. This one's a little more tricky, but from this problem we can denounce that this is h of d plus h of b over 2, which is 6. Now, if we have the ratio of di to de, oh shoot, that's not an e, that's very dysfunctional, but de, we're gonna have h of d minus h of I over h of d minus h of e. And then this is going to be equal to 3/4. Giving us that di equals dh is 9/2. Therefore, length CG is equal to 3/2 and SG is equal to 9. Now, if we drain out all the water, let's call that V, and then volume V for the volume without all the water, and then we have U for the other cube with the point S in it. So then we have U plus V is equal to 27U, which is going to be equal to SG over 6 times di squared, which is all we went through to do. We have SG SG is equal to 9 over 6. And then we have the value of DI, which is 9 over 2. This is 243 divided by 8. Now, we want the volume. And the volume is 6 cubed minus 747 over 4 when it simplifies. So we have from this, we are going to have that one right there. So then 747 plus 4 is equal to 751. And that is our answer for this problem.